Today, we're going to be tackling storage. Welcome back to another edition of Edit Space Improvements.
Everything that you edit has to live somewhere. It's simple, right? Get a USB drive, plug it in, and go. This is where most editors start, but as the quantity of work and budgets increase, storing your work on a collection of removable hard drives isn't going to cut it. We're not just talking about the safety of your precious footage, we're also talking about the ease with which you can access and share it and the speed at which you can work. This video is going to be a crash course in storage technology for video editors, and we're also going to show you what we are using for our storage.
Like a lot of people, FEP has a hybrid workflow, and it calls for both on-site and remote access to our storage. For example, Leon's in England and I'm in the US. And then even here in the US, we have trainers spread out from Los Angeles to New York using multiple workstations, all who need to access data simultaneously. Up to this point, each trainer has dealt with their own storage needs separately, and we've used Dropbox to work with shared files. It's an okay workflow, but it's not ideal, and it's honestly a little bit disorganized. My own workflow is basically a giant pile of USB hard drives.
I'm a little bit better set up than Chris, no offense.
None taken.
I'm already using a NAS. All of my data is in one place and I can access it from any computer on my network. I can even access it over the internet, but I've outgrown my current system, so I am upgrading as well.
A NAS is the perfect solution, and we're going to explain why. But first, chapter markers below if you want to skip ahead. And of course, please like and subscribe to see more content like this in the future.
Now, we'll get to this later, but first we need to cover some quick storage basics. First, data safety. Hard drives fail, SSDs fail. It's not a matter of if, it's a matter of when. That's why if you want your data to be safe, you need to have at least 2 copies. Or even better, you might have heard of the 3-2-1 policy. For your data to be safe, you should have 3 copies in at least 2 places at any one time. That way, if your office burns down, your data is recoverable. What's the big deal? What if I lose some data? Imagine if a client has sunk $1,000 or maybe $50,000 into a day of production. If you lose the rushes, the client will lose their money and you might lose a client. Or maybe you're storing years of your own footage and videos. How would you feel if you lost everything? Your data is worth serious money. Sometimes it's priceless. So, point 1, drives fail. It's not a question of if, it's a question of when. Next, drive speed. Not all storage is equal. Some is fast, some is slow. Now, footage is getting more and more demanding for computers to play. The key metric here is bitrate. How many bits does the computer have to read per second to play your footage back smoothly? Well, the drive must be faster than the footage's bitrate. And if you're playing several clips at the same time, for example when editing multicam footage, the drive needs to be even faster. So point 2, drive speed matters. Next, cost. There's 2 main technologies we use for storage: hard drives, mechanical disks with spinning platters, and solid state drives with no moving parts where the data is stored in memory chips. The faster a mechanical disk spins, generally the faster a hard drive can read and write. Hard drives are designed to spin either at 5,400 RPM, 7,200 RPM, or 10,000 RPM. Because solid-state drives have no moving parts, they are much faster than their mechanical counterparts. Sadly, they cost a lot more too. There's 2 main types of SSD, SATA and NVMe. SATA is slower but cheaper, NVMe is faster but more expensive. Either way, increased performance comes at a cost, so point 3, we're all on a budget. At some point you'll have to choose between high performance, low capacity, and low cost, high capacity. Redundancy. You might have heard of RAID. No, this video isn't sponsored by a video game. It's an acronym that stands for Redundant Array of Inexpensive Disks. It's a clever technology that helps you build larger drives and, depending on the type of RAID used, can provide protection against drive failure. RAID allows you to group several hard drives together into an array, and their capacities are combined into one giant drive. With certain types of RAID, some drives in the array are kept as spares. A sort of copy of your data is kept on those spare hard drives. RAID can give you an increase in performance, but more importantly, your array can sustain the loss of 1 or 2 hard drives without losing data, because it can instantly recover the data from the spare hard drives in the array. Now, this is incredibly important when dealing with large amounts of data and large numbers of hard drives, because remember, if you have 10 hard drives, you're 10 times more likely to experience a drive failure than if you have just 1. The same principles are true of SSDs too. So point 4, redundancy is crucial. Next, backups. The software that you use to manage your storage is important. Even if drive failure is never a cause of data loss, then at some point, human error will get you. You could drop a drive, lose a drive, or accidentally delete data. Or even worse, your office could burn down or be flooded, like we mentioned earlier.
It sounds like it might be a threat, Leon.
No, it's not. Remember, we mentioned the 3-2-1 data policy. Well, you're going to want a complete backup of your data, preferably in a different location. And if your backup system is reliant on you remembering to manually make a backup, well, what are the chances of you forgetting? Good software will help mitigate the chance of you accidentally damaging your data. Point 5, a reliable backup system is vital. And now that we understand those key concepts, we are ready to specify our own system.
Let's talk about the different options available. Option 1. Most editors start out with USB hard drives. They're cheap, but they do offer kind of poor performance. There's no automated backup, and they can only be accessed by one person at a time, and they're also time intensive to manage. The cost of these, though, is cheap, like I said, at around $16 a terabyte. Option 2. What about using USB SSDs, solid state disks? Now, of course, these are faster, so you're going to be able to work with higher bitrate footage. But you'll have all the other same problems that we have working with piles of USB hard disks. The cost of these is significantly higher at around $125 per terabyte. Big jump. Option 3. Premium storage devices like Promise Pegasus offer some advantages. They've got increased capacity and speed thanks to technologies like RAID, and they have limited protection against drive failure. But they can also get expensive. And still, they can kind of only be accessed by one person at a time. And the cost of these, somewhere in the middle, around $95 per terabyte. What's that? Did you just ask about a NAS? A network attached storage device? Instead of connecting to your computer via USB or Thunderbolt, a NAS connects to your network. Multiple users can now simultaneously access data over the network. It's basically a mini server. The NAS can even be set up for remote access over the internet and can automate tasks like backups. Let's look at some options here. NAS option 1. It's possible to build your own NAS using regular computer components, and you might even be able to convert an old computer. By sourcing components and assembling them yourselves, and then using an operating system like FreeNAS, it's possible to save money. It's going to take you more time though, and you got to think like how much is a day of your time worth. You're also going to be responsible for solving any issues that you encounter along the way. The price of this is around $50 per terabyte. NAS option 2. What about an enterprise-grade NAS? If you've watched any Linus Tech Tips, you've probably heard of Storinator. A device like that is aimed at IT professionals and networks with hundreds of users. The cost and learning curve on a piece of hardware like this might be a little bit prohibitive for users like you and me. After all, I'm a video editor, not an IT professional. This is around $200 per terabyte. Option 6. There are some manufacturers that make NASs specifically for video editors, like LumaForge with their Jellyfish range. This obviously seems like a promising option, so let's see how much it costs. That's not cool. Ultimately, I think that we can do a lot better here. There's a sweet spot, somewhere in the middle between those time-intensive solutions, like building your own hardware, and then those massively money-intensive pre-built solutions. And that brings us to option 7. Introducing Synology and QNAP. Now, both of these companies have an extensive range of NAS devices. Everything from like single drive units all the way up to rack mount servers. You can pick a capacity and a feature set that's going to work for you, and then you just basically install your own set of hard drives. The cost of this is actually only about $60 per terabyte. Not bad.
We're going with Synology. Firstly, because I've been using Synology for the past 10 years. I like their hardware and software, and there's no compelling reason for me to leave their ecosystem, so it's what I've recommended to Chris. Secondly, there is a particular model that I'm interested in. It's their 12-bay desktop NAS. Their range is easy to understand. The Plus series is a good mix of features and price. You should choose a model that will give you the capacity and performance you need. Think about how much storage you currently need and how much you are likely to need within the product's lifespan. Both myself and Chris are going to go with the DS2422 Plus, one each.
This is just basically a computer with a ton of hard drive bays. Now, we don't want the speed of our network to become a bottleneck here, so Wi-Fi is out. What we're going to need is a wired network.
Depending on your cabling and hardware, different networks run at different speeds. The most common network speed in homes and offices is 1 gig. Now, that's too slow for us. We need at least 2.5, 5, or even 10 gig networking. Faster is better, right? But also typically more expensive. A 10 gig network requires more expensive cabling, more expensive switches, and more expensive interface cards.
Now, fortunately for me, I already have a 10 gig network set up with all the cables and the switches and everything that goes along with that.
I'm taking the budget option. 2.5 and 5 gig can be run on much cheaper cabling, and the switches and NICs are cheaper too. Here's my plan. My cables are Cat5a. This Zyxel switch has a mix of 1 gig, 2.5 gig, and 10 gig ports. I'm going to connect my two workstations via the 2.5 gig connections and use one of the 10 gig ports to connect to my Diskstation. Interestingly, mechanical disks aren't fast enough to saturate a 10 gig connection, and 2.5 gig is more than enough for most video files. So 2.5 gig might not be as big an issue as you think. We'll run some tests later to see the performance difference.
The DS2422 Plus only has 1 gigabit network ports. To get 10 gigabits, you're going to need to install a 10 gig NIC in the Diskstation's PCI expansion slot. Now, you can use some third-party NICs, but just make sure that you check the compatibility if you do. We're going to use Synology's own E10 M22-T1 because this also has 2 NVMe slots, and we're going to be using those for installing NVMe M.2 SSD drives, which we'll be using for caching. So what about the actual storage drives?
We're going to fill the Diskstation with the biggest drives we can, and we want performance, so we're going to be speccing 7,200 RPM drives.
Most hard disk manufacturers make drives that are marketed specifically for NAS enclosures. They tend to have a higher price though. So what's going on there? Are these drives any different from their desktop versions? In short, yeah, there are a couple key differences. Having 12 drives squished together in one enclosure means more heat and it means more vibration. NAS drives are designed to tolerate both of these conditions better. They also have different firmware that's optimized for use in a RAID array. And finally, a lot of NAS drives come with extended warranties and free data recovery plans.
If you are on a tight budget, you might be interested in something called hard drive shucking. That's when you buy a USB desktop hard drive, open it up and pull the hard drive out. They're just normal SATA drives inside. I've done this in the past and I've had no problems. But it's only worthwhile if these hard drives are significantly cheaper than their enterprise counterparts. And at the moment, Seagate Exo S18s, the drives we're choosing, cost considerably less when compared to something like a Western Digital USB Essentials hard drive.
Finally, let's talk about those NVMe slots on the expansion card that we installed. We're going to install a 400 gigabyte NVMe in each slot. These are going to be used to boost the speed of the NAS by acting as read and write caches. When a file is written to the Diskstation, it's first written temporarily to the NVMe. The system then writes the data onto the slower mechanical disks next. Small files that are accessed regularly are going to be stored in the read cache for faster access. Also, performing a search on your drives is going to be much quicker now, because the cache is going to hold a readily available index of every single file name on the NAS. Now, it should be noted, SSD read and write caches are more beneficial for workflows that regularly access small files. Now, as video production revolves mostly around using large video files, the SSD cache won't have as significant an impact on performance for us, because the cache is just not going to be big enough to contain the footage. If I dump a 1 terabyte card of rushes onto the server, as soon as the cache is filled, the speed's going to once again just be limited by the speed of the mechanical disks. So, performance gains? Yeah, but don't expect huge leaps. There's one final thing that we need. It's not absolutely necessary, but it's definitely recommended, and it's a UPS, an uninterruptible power supply. In the event of a power loss, a UPS is going to keep the NAS running while it performs a proper shutdown. Whatever NAS you choose, look at its power consumption and buy an appropriately sized UPS. Remember, you don't need it to run for hours, you just need it to run long enough to be able to shut down safely. Mine is going to go in a server closet.
Mine is going under the stairs.
Setup is easy. Plug in and turn on, and then just configure via a web interface. There's going to be also on-screen instructions that'll help you along the way. We're using Synology's hybrid RAID with 2-drive fault tolerance. That means I can lose a total of 2 drives without actually losing any data at all. That's pretty good.
You'll need to set up users and configure their permissions. These are the credentials you'll need to enter when you connect to the NAS. You'll also need to create shares and assign who can access them. There are tools for configuring backups, setting up VPNs, and analyzing performance. There's even an app store for adding additional functionality to your Diskstation. This is my 4th Diskstation, so I'm pretty familiar with the process of setting one up. Chris, it's your first time though. What was the experience like for you?
Yeah, not too bad actually. I did do a little bit of Googling and going through the Synology help features to set up the users and the storage pools, but that information was pretty easy to find, so there was really no trouble. So far, I'm loving it. It's been fast, it's been easy to access from my workstation, from my laptop, and I like being able to organize all of my projects and my files onto one massive virtual drive, instead of having to remember is something on D, or is it on F, or is it on W, or wherever it might be. Much more organized.
Speaking of speed, it's time to test the performance. As a benchmark, let's look at the speed of an external USB mechanical hard drive, which will typically cap out at about 70 megabytes per second, and a USB-C solid-state drive. They can typically transfer between 500 and 1600 megabytes per second, depending on the model. Now let's check out our Diskstation. Over a 1 gigabit network, I'm getting about 100 megabytes per second for both read and write using the drives in the Synology. Over a 2.5 gigabit network, I'm getting around 250 megabytes a second. Chris, how's it handling on a 10 gig network?
I'm getting around 450 megabytes a second for both read and write, and that's going over a 10 gig network, which theoretically can support transfer speeds of around 1,250 megabytes per second. But of course here, we're limited by the speed of the actual hard disks that are set up in our RAID. So a huge improvement over USB hard drives. Not as fast as locally attached SSDs, but if I wanted to, I could have filled my NAS with SSDs, although it would have cost around 6 times the price based on the amount of storage that I was looking for. As it is, it's considerably faster than what we need for the high bitrate video files that we work with. And obviously it has all the additional advantages that we discussed of using a NAS in the first place, so in my book, that's a win.
Are Synology Diskstations any good? It's time for a mini review. Now, full disclosure, Synology kindly provided us with these Diskstations, but we approached them, they didn't approach us. We had already decided on getting them, and Synology liked the idea of us making a video. We did purchase the drives that we put in ourselves. Now, it's my 4th Diskstation, and I'm still using all the previous ones I've purchased in the past. I use them for backups and offsite storage. And I keep on getting more, so yeah, I think they're pretty good. For me as an editor, they're the right mix of value, performance, and convenience. Now, the best thing about them, in my opinion, is the software. It's a living, breathing operating system that Synology continuously updates. It handles all the boring, important stuff that you need to do to protect and access your data seamlessly, stuff like VPNs, remote access, backup tasks, media servers, and more. Here is my one gripe though. Synology have always maintained a list of recommended drives for their NAS. Recently, on particular higher-end models, this one included, Synology have introduced a warning when a user installs a drive that doesn't appear on their compatibility list. Additionally, their compatibility list in this instance is restricted to Synology's own branded hard drives, which are considerably more expensive than other suitable alternatives. Now, this move has annoyed a lot of people. In Synology's defense, there's good reason to encourage users to use their own drives, increased performance and easier maintenance being two of them. Now, I'm using high-quality Seagate Enterprise hard drives in my Diskstation. There is no need for this silly warning that appears permanently in my interface. Now, please note, it doesn't affect operation or my warranty in any way. By all means, Synology, please warn me, but let me turn the warning off. Apart from that, it really is a great product. And maybe Synology will rectify this issue in the future. And in the meantime, it's not a reason not to buy one. I just thought I should mention it.
So what would this setup cost? I've only filled half my bays currently. For my 72 terabyte setup, with 2-disk redundancy, it's cost about $4,200 US.
How does the cost stack up? To make comparisons easier, we're going to compare the cost of 72 terabytes of storage for each solution. A pile of USB hard drives costs about $1,320. You'll get shoddy performance, only one person can access your files at a time, and there is no redundancy. A pile of USB SSDs would cost about $6,840. Now, the performance would be amazing, but I'd need 18 USB ports, and without a complicated RAID setup, they'd all be separate drives, and of course, they would still be difficult to share. A premium RAID desktop hard drive costs around $4,000 to $5,000, depending on brand and features. You'll get much better performance with some redundancy, but it can still only be accessed by one person. A DIY NAS will cost around $3,000. It's only going to be slightly cheaper as you've still got to spend the same money on the hard drives, and you're going to have to spend time building and configuring it. And finally, a premium video editing NAS will cost you maybe around $20,000. That's a lot of money for basically the exact same performance. Now, when you look at this solution in context, I think it's good value. Any increase in cost is negated by the extra functionality. I now have a secure, accessible, and reliable storage solution that's going to serve me for a long time. And if my storage needs grow, well, I can expand my existing system. I don't need to replace it.
As a professional editor, every purchase that I make needs to make or save me money either directly or indirectly by helping me to do my job more effectively. So who pays for all this? Simply put, the client. If a client books a cinematographer for a shoot, he either has to rent him a camera or pay the cinematographer a fee to use his own camera. As an editor, you have overhead: office space, electricity, computer hardware, software licenses, and of course, storage. There's two ways of passing those costs on to your client. They either need to be reflected in your day rate, or on a given project, you might charge a modest fixed fee.
Who is this kind of kit appropriate for? Everyone. It can work for a single freelance editor. It can work for a post house with multiple users. Choose an appropriately sized NAS. Don't be afraid to get more bays than you need, and then buy as many hard drives as you currently need, and then scale up, add more as you grow. It's easy to overlook storage. Borrowing from Chris's illustration, if a cinematographer turned up to a shoot with their mobile phone, the client's not going to be impressed. They expect you. No, they are paying you to have the appropriate equipment for the kind of work that you take on.
In general, we've done a little bit of talking here behind the scenes at Film Editing Pro, and we want to make more videos about post-production hardware. We talk a lot about software, and of course we talk a lot about creative editing techniques, but the equipment that we all use is obviously hugely important as well. So by all means, please put ideas, put questions, anything you can think of down in the comments. We'll check them all out, and you'll probably have a pretty big influence on what topics that we end up tackling next. Thanks again for watching.
Hey there! For tons more free editing training, head over to our website at filmeditingpro.com/free training. Here you can download free editing guides along with high-quality video training courses created by our team of professional Hollywood editors. Our tutorials cover a wide range of editing topics, like cutting awesome movie trailers, editing action scenes, how to work with music and sound design, and a lot more. All of these free guides and videos are available at filmeditingpro.com/free training. I'll see you next time.